Hey guys, hi. Very good evening to all of you and welcome to the sessions. How are you all? कैसे हो तुम लोग? I'm very thankful कि the kind of response which I'm getting from you guys is overwhelming. It's outstanding and I'm very happy for that. और मैंने पहले भी कहा था कि आपके जो responses रहते हैं, the kind of enthusiasm which you show, that gives me that motivation to make more such videos. I was just going through the video. सिर्फ 3 दिनों में it has been viewed by more than 1500 students all across India, and I've got more than 50 comments, 60 70 comments, something like that, and still pouring on. I'll just take the names for a few of the students. एक बार मैं बता देता हूं because most of them have given 2 awesome comments. So right now I'm able to see Prakash, Raghav, Chopra. I'll not be able to take all the comments कि उन लोगों ने comment में क्या लिखा है, but these students, they are just pouring in their thanks and all those things. So Prakash, Raghav, Akash Kumar, Ayush Sharma, Hardik Thunderstorm, curious video for you. Manjula, Sasmita, Imuddin Chishti, Archit Roy, Ayush Sharma, Padmavati, and then Ankita Kumari, Alfia, uske baad Naveen Maurya, Vinayak's Interthoughts, Amit Tripathi, Kaustubh, Sharat Kumar, Akhilesh, Nitish, Alfia, Rithanya, Rafiq, Manoj, ERV TV, Jayant D, Rahul Saha, Kaustubh, Priya Tripathi, Muzammal Ali Khan, Think Big, Do Big, and Ankita Singh. So very thank you to all of you guys, and I'm really happy that you all are liking this video and this whole concept so much. It gives me a lot of pleasure. ऐसा फील होता है कि हाँ, मतलब जो कर रहे हैं वो वहां तक पहुंच रहा है जहां तक भेजने के लिए इसको बनाया था. So with this thought, I'll be starting today's session, and I'm really happy, super duper excited with the response from which you people are giving me. 3 दिन में 1500 views कम नहीं है. Okay, so let's start, guys. In the previous session, what we had done? In the previous session, we had done expressing the HCF in the form of linear combinations. Okay, where we had written done the HCF of 2 numbers. And then we represented in the form of linear combination of 2 numbers. And thereafter we proved that the value of m and n or p and q whatever is not unique. So we proved this thing. So with this, let's move forward in the sessions and try to know something more. Okay, real numbers. उससे आगे बढ़ने से पहले I'll just give a brief glimpse what we had done in the previous class, ताकि कुछ भी भूलो ना. So Euclid's division algorithm we had studied. And say for example, I'm just revising it once again, ki how to find the HCF of 2 numbers using that division method. So say for example, if we have the division algorithm and we have to calculate HCF of 171 and 99, then how are we going to do this? So let's see how we are going to do this. First, how many steps are there in the solution is being asked. So how many steps means basically they are asking that how many divisions we'll have to do. Okay, that is the concept. So how many divisions we'll have to do? Let's do smaller number as the divisor, then larger number 171. It will be in 1 times, so I'm doing 1 times. Remaining is 72. New divisor, old divisor will become my dividend. We had done this. Again 1 time, so this is 72. And if I am not wrong, so this is 27. So this is 27, so this 27 again 72. I'll be dividing it in on 3 times perhaps. Yes, 3 times. No, 3 times नहीं, 2 times में हो पाएगा. It is 54. Remaining is कितना आ रहा है बता दो. If I am not wrong, it is coming as something around 18. हाँ 18. So I'll just write 18 here, 18, and then 27 will come. So this is 27. Again in 1 time. So this is 18. Remaining is 9. 9 will divide 18 in 2 times. So 18 cross. So how many steps we took? So how many divisions we did? Just we need to check it out. 1, 2, 3, 4 and 5. So we took all 5 divisions, isn't it? So once we took this 5 divisions, the answer will be 5. I hope you all would have understood, isn't it? So that was very easy. I just recapped what we had done in the previous session. This was the division, what we had done in the previous session, how to divide. Sorry, not how to divide, how to find the HCF. Now if you have understood, let's move ahead, guys, with the next question. So this is the answer. We have done this many divisions, and in the previous session I have even said you how to write it in the form of Euclid's division algorithm. because writing it in the form of equation is also important. Why? Because in the previous session we had talked about that this is the remainder line and we will be using this remainder line only to get that to express this HCF in the form of linear combination. We have done all these things. Okay, so let's move ahead. Here goes the next question. Next question says, prove that the square of any positive integer is of the form 3m or 3m plus 1, never of the form 3m plus 2. Okay, so this is another type of question where most of the students face difficulties. Sir, how to prove these kind of questions where we have to prove something like this, ki 3m plus 1, many times it comes 4m plus 1, 9m, 6m, anything. So the punchline here is, whenever you are being given that you have to prove square, cube or anything, or odd integer, positive integer, so in whichever form you have to prove, you will assume the number in that form. What I said, see here, you have to prove that integer is in the form of 3m or 3m plus 1. So what is the divisor here? 3. With divisor, what do I mean? I mean that you must be knowing a is equal to bq plus r. Suna hai? So a is equal to bq plus r, dividend equal to divisor into quotient plus remainder. Now you all know we can take any divisor here. So this value of b, I can take any value. So I will take the value which is given in the question itself. I'll take this value only, 3. Okay. So I'll take my number, prove that square of any positive integer. So I'll just write here, let the integer be, let the number be n. I have assumed it n. You can assume it x, y, whatever you want. So if number is n, I'll write that number n is equal to 3q plus r. Number will be 3q plus r. Now, in Euclid division algorithm, we have learned this thing that one rule is there that remainder will always be less than the divisor. Remainder will always be less than the divisor. So, remainder less than 3. So, what are the possible values of remainder? Remainder can be 0 because less than 0, negative remainder is not possible. So, 0 remainder or 1 remainder or 2 remainder. If we divide any number by 3, these are the only possible 3 remainders which we can get. Okay. So, if you have understood, now I'll write n is possible to be 3q or n is possible to be 3q plus 1 or n is possible to be 3q plus 2. With these 3 remainders, 0, 1 and 2. So, if 0 remainder, this is. Now, we are not being asked for the number. We are being asked for the square of any positive integer. Square. So, we are being asked the square of the number. So, just square it. So, I am just writing square means n square. That is equal to 3q whole square. So, that is 9q square. Are you able to see that here I can write it like 3 into 3q square? 3 into 3q square. Okay. अरे हाँ, इस गलती से याद आया. In the previous video, probably I have done a mistake of minus 52 and minus 4, and by mistake I had written minus 48. Many of the students have even put that in the comment ki sir you have done it by mistake, minus 48. It should not be minus 48, it will be minus 56. Minus 56. अभी इससे याद आया कि हाँ वो minus 52 और minus 4 को मैंने minus 48 लिख दिया था. So please make that correction. It was just a normal calculation error. हो जाता ना, silly mistake. Okay. So I can write this 3 into 3q square. Now, can I say that this number is a multiple of 3 because it is being multiplied by 3? Although it is a multiple of 9, so it will be a multiple of 3 also. So 3 into any number m. So I am assuming that any number as m. Okay. So 3 into m, that is 3 multiple of 3. So I have proved that the first form, if I do the square, this square of this number is of the form 3m. Okay, 3 multiple. Now, if I similarly, in the same fashion, if I do the square here, n square, I'll get 3q plus 1 whole square. I'm directly writing. It will be 9q square plus 6q plus 1. If you are able to understand, I have squared both sides. Now, are you able to see that from these two terms, I am again able to take out 3 common? So, I will be writing this 3 taken as common, and whatever the number is coming inside, I'm just assuming it again a multiple. See, I'll just write it in the rough. It will be, when 3, I'll take 3 common, it will be 3q square plus 2q. So I can assume this number as m, na? this number as m. So this is 3m and here it is plus 1. So again square of this number is 3m plus 1. Now the last form is remaining. If I square here n square, that will become 9q square plus 2ab, 2 3 is 6, 2 is 12, 12q plus b square. So b square is 4. B square is 4. Can I write this 4 as 3 plus 1? Now you'll ask me, sir, why? Why have you written like this? I'll tell you. If I can write it like this, are you able to see that from all these three terms, I am able to take out 3 common? So I can write again 3 multiple, because if I am taking 3 common, whatever remaining inside will become a multiple, and plus 1 is remaining. 3m plus 1. So this was our objective which we have to prove, that if I square any number, I have taken any number in the form of any divisor, that any divisor is 3, because in the question we have to prove that. Now 3 with divisor 3 numbers are possible, 3q or 3q plus 1 or 3q plus 2. Now I squared all of them. Once I squared all of them, I got that all the numbers are in the form either 3m or 3m plus 1. And this which we have to prove. And let me tell you, this type of questions come in the exam predominantly either in 3 marks or in 4 marks. Mostly it comes in 4 marks, but sometimes it might come in 3 marks, but it never comes in 2 or 1 marks. So it's a very good question and very sure short question. This type of question will be coming. So I have taken a few other types of this question also. So I'll just show you. So I hope you have understood. If you have understood, let's move ahead, guys. So this is a solution. If you want, you can take a snapshot of this also. Okay. So this was the case. We have also made 3 cases. First case 3k squared, so 3 multiple. Second case 3k plus 1 squared multiple 3m plus 1. And third case 3k plus 2 squared and then getting 3m plus 1, again in this format. So A was of these 3 types and A square will be of these 3 types. 3m, 3m plus 1 and 3m plus 1. So this is 3m, 3m plus 1, but never 3m plus 2, which we had to prove that it is never 3m plus 2. So it is never coming as 3m plus 2. So I guess you have understood. Here goes the next question. Now this type of question will also be there. One type was a square, one type will be cube. Now pay attention. See here. Here it is saying that cube of a positive integer, now that again is any positive integer, is always of the form 9m plus k. So I have just now said that you will assume that number. So I'm just assuming that number, say for example n again. Now n can be written as bq plus r, again very simple. So here bq plus r can be written, and this bq plus r, so this b can be anything, so I'll take this 9 because here it is in the question. So 9q plus r. Now what can be r? R can be any value. R can be any value less than 9 because it should be less than the divisor. But just imagine here, then r will be 0, 1, 2, 3 till 8. Won't it be too many numbers? Means it will take us something around 9 pages or 8 pages to prove this. So is there any shortcut method? Yes, there is. Now see here, we already know that if I'll do cube or square even of 3, I will be getting this 9. Do you agree this? We have to prove it in the form of 9m plus k. So if I simply take the divisor as 3, because we have to do cube. So if I'll do the cube of 3, we will itself get 9 always, isn't it? So here I will not take 9 as my divisor, rather I would take 3 as my divisor, so that my remainder should be only 3 values, 0, 1 and 2. Okay, understood? So I'll just show you. See here, let's solve this. I'll show you. So here what we are going to do, we are going to take the number, say for example n is equal to 3q plus r. Now r will be having multiple values 0, 1 and 2. So I'll take again cases. Case 1, that n is equal to 3q, or case 2, that is n is equal to 3q plus 1, or case 3, that is n is equal to 3q plus 2. So I have taken these 3 values, isn't it? Now here we have to do the cube.
So let's do the cube. This implies n cube. Very easily you are able to see that it is 27 q cube, and here I can take 9 as common, so it will be 9 multiple, isn't it? 9 multiple. Now we have to find what are the possible values of k. So first of all we have to put it in this form. So here if I am writing 9m plus k, so here there is no plus, so this means plus 0 is there. So I can write 9m plus 0, does not make a difference. So here the value of k is 0. Now second situation, here also again I can do the cube, n cube. So I'm just doing the cube directly, a plus b whole cube. A plus b whole cube you must be knowing. So I'm writing a cube, that is again 27q cube. A cube plus 3a square b plus 3ab square plus b cube is the formula. So if I'm writing 3a square b, so 3 into a square is 9q square into 3 is 27q square. Just do it on the rough in your copy, you will be able to understand more. Then 3ab square, so 3 3s are 9q and 1 square 1. So plus 9q and plus 1. Again take a note that from all these three terms I will be able to take 9 common. So this is 9 multiple plus 1. And similarly in this case, again if I will be doing the cube, I'll get n cube, that is 27q cube plus 3a square b, so 3a square is 9q square, 3 27, 2s are 54. So it is 54 q square plus 3ab square. So 3a means 3 into 3q, that is 9q into 4. 9q into 4, that is 36. And plus 4. Again, you are able to see that from all these three terms, you are able to get 9 as common. So it will be 9 multiple plus 4. So what did we get basically? We got a very beautiful thing here. That beautiful thing is that the value of k is either 0, 1 or 4. Now, let me tell you, this question would have been asked, this question could have been asked into multiple ways. How? Here it is written that cube of any positive integer is always of the form 9m plus k, where m is a whole number. What are the possible values of k? They are asking possible values of k. Second version of this could have been that if I am doing cube of any positive integer, the number will always be of the form 9m plus 1 or 9m plus 4. Prove this. So you could have done the same method for proving the same question. Okay, it could have been in a form of prove, it could have been in a form of asking a question or anything like this. So in all such type of questions, this will be used. I hope you have understood. If you want, you can take a snapshot. Let's move ahead. And it's a very simple question, and let me tell you, this question is predominantly 4 marker question, not even a 3 marker question. So surely this type of questions is going to come in 4 marks only. So move ahead. So here is the solution also in the very same fashion. 9m plus 1. Oh sorry. फिर से गलती कर रहा था. फिर तुम लोग बाद में लिखते सर वीडियो पे. आई एम वेरी सॉरी, मैंने वहां पे देखा ही नहीं ध्यान से. कहां गया? 2 cube is not 4. 2 cube is not 4, it is 8. 2 cube is not 4, it is 8. So by mistake there I have written 4. So the values possible is 0, 1 and 8, not 4. I have written 4. So this is the value 8. So please make the correction in that previous part. Okay, चलो आगे बढ़ते हैं. Thank you. अच्छा वो यहाँ पे solution दिख गया, ध्यान आ गया. Okay, ये सब छोटी मोटी मैथ्स में होते रहती है. So here is the next question, guys. A very beautiful word problem, and I am very sure that in word problem also many of the students find difficulty saying that कि सर ये word problem समझ नहीं आता कि HCF निकालें कि LCM. What has to be calculated in the word problem because it is not mentioned there. So how will you figure it out that what has to be taken out? चलो देखते हैं. Here it is being said that there are 2 petrol tanks A and B. चलो अच्छी बात है, A and B. This is petrol tank. Okay. So in this petrol tank A and B, capacity is 850 liters and capacity is 680 liters. What is the capacity of biggest measuring container that can measure both A and B? मतलब हमें करना क्या है कि हमें इसमें से जो ऑयल है उस ऑयल को, जो पेट्रोल है उस पेट्रोल को मेजर करना है. You just tell me one simple thing. इसमें से अगर पेट्रोल मेजर करना है, मतलब मेजर करना मतलब मेजर कर करके निकालना है, तो अगर मेजर करना है तो यू विल यूज अ स्मॉलर कंटेनर, मतलब सम जग काइंड ऑफ थिंग, या फिर एक बड़ा सा हैवी बड़ा सा कंटेनर लोगे और तब मेजर करोगे. You would not be able to measure it. Say for example, अगर इसमें 850 liters है, and if you take 1 liter container, then you can measure it in 850 times. After getting 850 containers of 1 liter, you will be able to figure it out कि हाँ 850 liter of oil is there. So measuring container will always be a smaller container. Very sure, isn't it? Now, if it is a smaller container, then you just tell me that this means that we have to get a value, we have to find a value which is less than the given quantities. Clear? Less than the given quantities. Okay. Now, if you have understood this, then one simple thing, one simple rule. Always remember, if in the question the value which is being asked from you is a lesser value than the given quantities, lesser value. So lesser value will always correspond to highest common factor, highest common factor. Always remember this works vice versa. If the value which is being asked is lesser, then highest common factor. If the value being asked which is required in the answer is larger, if it is larger, then you will find lowest common factor, lowest common multiple, lowest common multiple. Agreed? Understood? Now, so let's find the HCF. It's very easy again. Okay, so let's find it. 680. So what can I write for 680? 10 to sab mein hai, 10 is there. So 68 can be written as, if I am not wrong, it is 2 into 2 into 17. 17 fours are 68. 850. So 850. Again 10 to hai yahan pe. And what can be written as, I guess it can be 5 into 17. Yes. So I guess you are able to find the common factors. 17 and 10 is the common factor. So HCF, very easily, HCF is nothing but 170. Understood? Okay, fantastic. So this was very easy. In this word problem, they are very, very easy. Only you have to understand which part has to be found, HCF or LCM. हाँ, कभी कभी ऐसा होता है एग्जाम में कि सर कुछ समझ नहीं आ रहा है तो HCF LCM दोनों निकाल देते हैं, लेकिन ऐसा मतलब एग्जामिनर फिर बेवकूफ नहीं है, वो 2 मार्क्स नहीं देता है. नहीं, कुछ लोग सोचते हैं कि सर ऐसा करते हैं ना, या तो HCF निकालना होगा या तो LCM, दोनों ही निकाल देते हैं, कुछ ना कुछ तो मिल ही जाएगा. This does not work, don't do that. Okay, so let's move ahead. So this is the answer, 170 liters in the very same fashion. Here we have done it using the long division method. Whatever method you want, you can do that, because here method is not mentioned. Okay, so let's move ahead. Now this is the next type of question which comes in this chapter, and very important type, that you have to find that which of this following number is giving non-terminating decimal expansion. Now, very important thing, how to find that whether the fraction is terminating or non-terminating. So always remember one thing, one simple thing. Terminating. In all the cases, you have to watch only the denominator. You have to watch only the denominator. So in the case of terminating, if the denominator contains 2 or 5 or 2 and 5 both. What I have said? If the denominator contains 2 or 5 or 2 and 5 both, okay, then it will be terminating. This is the condition for terminating. For non-terminating, any other number than 2 and 5 means if any other number is coming other than 2 and 5, maybe that 2 and 5 might also be there, but if any other number is coming other than 2 and 5, that will make your whole fraction non-terminating. Now this has to be seen only in denominator. Now one very important thing, say for example if I am writing 3 divided by 6, so if I see here the 6 has got 2 into 3, so 2 is there but 3 is a number other than 2 and 5, So surely it should be a non-terminating decimal. But when I solve this, 3 will be cancelled and it will be 2, so it will be 1 by 2. But now it is terminating decimal. So always remember that whenever you are inspecting the denominator, make sure that your fraction is in the simplest form. Simplest form is the punchline. You have to make sure that your fraction is in the simplest form. So here also we will apply the same thing, 2 and 5 concept, but we'll make sure first that all the fractions are in their simplest form. So let's make those fractions in their simplest form first and try to understand how this is going to be solved. Chalo, shuru karte hain. So if I make it in the simplest form, this will be 4 cancelled, so it will be 21, 4 cancelled 15. Again 3 is being cancelled 7 times and 3 is being cancelled 5. So this is 7 by 5. So surely this is terminating because 5 is there, so terminating. Again come here. So 8 7s are 56, so 7 will cancel 5 and 7 will cancel 8. So here 8 is coming, so this is 2 cube, only 2 is there, so this is terminating. Now 699, cancel it by 3, so it will be 2, cancel it by 3, it will be 33. So we got 2 by 33 and 2 by 33, here 33 has 3 into 11. So surely this is non-terminating. Did you all understand it? Non-terminating means any other number other than 2 and 5. So we have another number other than 2 and 5, and that is why it is non-terminating. So if you have understood this, let's move ahead and see some next type of question, some other type of question. Sorry. यार ये अंग्रेजी घिसते ना. हाँ, so this is the answer. So let's move ahead. Chalo, this is the second type of questions. How many digits are there in the decimal expansion 18 by 240? So again, this is also a different type of question, but concept would be same. Means applied concept would be same. I'll tell you. First thing, very important, make sure that this is in the simplest form. So just make it in the simplest form. Cancelled by 2, I guess. So if cancelled by 2, I'm not 2, 6. So 6 3s are 18 and 6 40. So this is 3 by 40. Very good. Now come to the denominator again and do the prime factorization. So if I do the prime factorization for 40, I'll get 2 cube into 5. Now first of all, if here how many digits are there in the decimal expansion is being asked, then one thing is very sure, that surely that this fraction is going to give terminating decimal, because if it would have been a non-terminating decimal, then the number of digits would have been infinite, isn't it? So here it is terminating. So in terminating, this is very sure that we are going to get only 2 and 5. No other than that. No other number other than that. Now, so how to find number of digits in the decimal expansion without doing the division? Very simple. You get the number 2 and 5 and you get their power. There is no power, so 1. Now whichever number is larger, 3 or 1, whichever power is larger, that will be your answer. Here 3 is larger, this means 3 digits will be there in the expansion, and answer would be 3. Simply, no other rocket science. Very simple. Okay, so just make sure that you get your fraction in the simplest form, then you do the prime factorization, then you write it in the form of 2 power and 5 power. Whichever power is higher, that is your answer. Sure, means a complete one-step solution. Okay, so let's see the solution. This is the answer, and I guess you would have understood it. So if you have understood, guys, that was all from my side for today's session. I'll be seeing you again on Monday, and I really love to come in front of you because of the comments and the motivation which I see from you guys. It gives me a lot of motivation and enthusiasm to make more such videos. So I'll be coming in front of you all again on Monday with proof of irrationality as the topic, because someone was saying ki sir, how to prove root 2, root 3 and all those, and even in your polls proof of irrationality was the second highest rated topic. So I'll be coming in the next session with those questions, some very beautiful questions, and that too some beautiful concept which will make your answer solving much more easier. So see you guys in the next session. Till then, bye bye, take care, keep enjoying and keep watching. Bye.